transistor is a bipolar junction transistor. Bipolar means we are going to consider both majority and minority charge carriers. And transistor is the transfer of resistance, that is one level, that signal is transmitted from one level of resistance to the another level, that is either maybe from low to high and high to low. Basically transistor inbuiltly consists of two diodes, that is pn junction diodes are consists of two pn junction diodes, those are connected back to back. There are three terminals present in transistor. Those three terminals are emitter, base and collector. The basic applications of transistors are amplifiers, oscillators, and it can be used in so many types of analog and digital circuits also. Basic operation of transistor is it can be acted as a switch on, it can be acted as a switch also. That is the basic application of transistor, on off switch. And thereafter it is the layered type of transistor, that is a p-type material is sandwiched between two n-type semiconductor materials. From this layered type of npn transistor, I am going to draw three terminals, that is emitter terminal, base terminal and collector terminal. This is the layered diagram. Similarly, this is the layered diagram for PNP transistor, that is p-type, n-type and p-type. From these three terminals I am going to represent those three terminals as emitter, base, and collector. This is the symbolic representation of transistor. That is, if arrow mark tending outwards, if arrow mark outwards means it is NPN type of transistor. If arrow mark inwards, then I can call this transistor is a PNP type of transistor. This is the same transistor can be represented with diode representation. This is the diode representation of transistor. That is this is a cathode terminal, anode terminal, and cathode terminal. This cathode terminal can be given as N type of semiconductor material. This is P type, and this is P type, and this is N type. Like that, we can represent here. That is those two cathode terminals can be given as emitter. In between anode terminals, this is base, and the extreme cathode terminal, this is collector. Emitter, base, and collector. In the similar fashion, the anode terminals are connected extreme ends, and between cathode terminals, I am going to draw one terminal, that is base terminal, with respect to the PNP type of transistor. In this way, we can connect inbuilt two diodes, and we can represent three terminals here. Okay. And basic function of this emitter is which emits majority charge carriers. It is going to emit majority charge carriers, that is with respect to the semiconductor material we are going to use, that depends upon p type. If I am using the majority p type of semiconductor material, I can the majority charge carriers will be holes. If I am using n type, then the majority charge carriers are electrons here. Base here emitter, which emits electrons or injects electrons, majority charge carriers into the base, like that. Whereas base terminal, this is a emitter terminal is a heavily doped, but width of this region is moderate and width is moderate. Base terminal, this is very lightly doped, it is very lightly doped but thin. The width of this region is very thin, that is in the range of 1 micrometer, like that. Collector, this base terminal which is used to bypasses the majority charge carriers. Collector terminal, the main function of the collector is to collect the majority charge carriers. It is going to collect majority charge carriers through the base, and it is moderately doped. Its doping level is moderately doped, but the width of this region is large. Width of the region is large. In the emitter, the width is moderate, but the doping level is very high. Base region, the it is lightly doped, but the width of this region is very thin. Whereas collector, this is moderately doped, but the width of this region is very high. Okay. In this, we can differentiate whether the transistor is PNP type or NPN type, depends upon the arrowhead indication. If the arrowhead is inwards, that is PNP type. If the arrowhead outwards, that is NPN type. Next one, this is the layered type of representation. I am considering the layered type of representation transistor. This is the NPN. I am considering NPN type of transistor. Why? Because by taking the N type of semiconductor material, the majority charge carriers are electrons. The frequent flow of electrons will give the automatically we will the current conduction will be high in the N type semiconductor material. So I am going to take here NPN type of transistor. Okay, transistor. Here transistor is just like a two diodes. The junction between emitter and base, the junction between this emitter terminal as well as base terminal, these two terminals, the emitter junction between emitter and base, these two terminals, I am going to acquire one junction here, that is going to be acquired one junction. That junction is depletion region. This is P type and N type semiconductor material is sandwiched. Then I am going to acquire one region here. That region I can treat this region as depletion region at junction JE. This is I am going to take this region as JE here. JE, that means emitter junction. Emitter junction. Let it be, this emitter junction is very small, very small. How it is small, we will see. How it is going to be small, we are going to analyze further. And and this is p-type material and n-type semiconductor material. Due to the p-type and n-type semiconductor material sandwiching, and one depletion region is going to be created and junction is get created. That depletion region at junction JC, it is this depletion region is large. Normally it is going to be large, and that junction is in between base and collector. That means this base terminal is common between emitter and collector. Base terminal is common. This base terminal is common between emitter and collector. Okay. Transistor is just like a two diodes. This is one diode. This is, let it be, this is one diode, and this is another diode. Let it be this emitter and base. We can call this as this is the combination of two diodes. I can call this diode as emitter base diode, emitter and base diode. And similarly, simply we can call this as this junction as emitter junction అంటున్నాం కదమ్మా. ఇది ఎమిటర్కి ఇంపార్టెన్స్ ఇస్తున్నాం కాబట్టి I can call this as emitter junction. Simply I can represent this diode as emitter diode also. Simply this is the common terminal between both the collector and collector and emitter. So I can take the importance with respect to the emitter only. Only emitter is going to be considered, and collector is going to be considered. Why? Because this is the common terminal, that is base here. Okay, that means I can take this p-type and n-type semiconductor material as one diode, that is base emitter base diode, emitter base diode or emitter diode. Simply emitter base diode or emitter diode. Next, the junction between base and collector, this is the base and collector, may be called as collector base diode. I can represent this p-type and n-type semiconductor material as collector base diode, collector and base diode or collector diode. Simply I can represent this as emitter diode. I can represent this as collector diode. ఈ టూ రీజన్స్ని కలిపేమో ఎమిటర్ డయోడ్ అని పిలుస్తాను. ఈ టూ రీజన్స్ని ఈ టూ రీజన్స్ని కంబైన్ చేస్తూ కలెక్టర్ డయోడ్ అని సింపుల్గా చెప్తాను అనమాట. అది that is I am going to acquire two diodes here. One diode is emitter diode simply, and another diode is collector diode. That emitter diode is in between the layers emitter and base, whereas this collector diode, that region is between collector and base. Okay, next one, the emitter diode is always forward biased. This emitter diode, it is going to be always forward biased. ఎందుకు ఫార్వర్డ్ బయాస్ అనేది రీజన్ వీఆర్ గోయింగ్ టు సీ ఇన్ ది సబ్సిక్వెంట్ సెషన్. డోంట్ వరీ, it is going to be emitter diode is always going to be forward biased, and the collector diode is always going to be reverse biased. It is emitter diode is always forward biased, the collector diode is always going to be reverse biased. This is the one. This is emitter diode is always forward biased, while collector diode is always reverse biased. The resistance of emitter diode, ఇప్పుడు ఇది ఫార్వర్డ్ బయాస్ కదమ్మా. ఇది ఇప్పుడు ఇది ఫార్వర్డ్ బయాస్లో ఉంది కాబట్టి ఈ పిఎన్ జంక్షన్ డయోడ్ ఏమవుతుంది? దిస్ పిఎన్ జంక్షన్ diode is in the forward bias condition, then this emitter diode is in forward bias condition, then I can treat this flow of current is very high. In the forward bias condition, the flow of current is very high, then the resistance part is low. That is the point given here. The resistance of emitter diode is very small, is very small when compared to the collector diode. This is reverse biased. This is reverse biased. The depletion region is large. ఇక్కడ ఈ డిప్లీషన్ రీజన్ థిన్ అని చెప్పాం కదా, ఇక్కడ స్మాల్ అని చెప్పాం. ఎందుకని? ఈ పీ రీజన్ ఈ ఎన్ రీజన్ని ఫార్వర్డ్ బయాస్ చేసాం అనమాట. ఈ ఫార్వర్డ్ బయాస్ చేయటం వల్ల ఈ రీజన్ ఏమవుతుంది? డిప్లీషన్ రీజను ఫార్వర్డ్ బయాస్ వల్ల at certain point by increasing the voltage levels, this region is going to be vanishes. This depletion region is going to be vanishes in the uh, preliminary stages. It is going to be very thin. The depletion region is going to be very thin in nature, whereas the depletion region, it is a reverse biased diode, therefore the depletion region is very large here. It is going to be large. That is the meaning. Why? Because this region is forward bias condition, therefore the flow of current is very high, its resistance is very small, whereas this region is very large, its the flow of current is very low, and its resistance is going to be high, and there is a opposition of flow of current will takes place in the reverse bias direction, therefore its resistance is large. That is the point given here. The resistance of emitter diode is very small as compared to the collector diode అని చెప్పి ఆ పాయింట్ చెప్తున్నారు అనమాట ఇక్కడ. The resistance of emitter diode is very small as compared to collector diode. And when no battery is connected, when no battery, this is no battery connection state. ఇదే లైడ్ డయాగ్రామే. ఎన్పిఎన్ టైప్ ఆఫ్ ట్రాన్సిస్టర్ తీసుకుంటే మనం ఎటువంటి బ్యాటరీ కనెక్ట్ చేయలేదన్నమాట. కనెక్ట్ చేయనప్పుడు ఏమవుతుందో చెప్తున్నారు. వెన్ నో బ్యాటరీ ఈస్ కనెక్టెడ్ between different terminals, transistor is said to be unbiased state. No voltage is applied to the transistor. I can call that transistor as unbiased transistor or open circuit stage. I can simply treat it as ఓపెన్ సర్క్యూట్ స్టేజ్. అంతే కదమ్మా. ఇప్పుడు మనం పిఎన్ జంక్షన్ డయోడ్లో ఇనిషియల్గా ఏం చెప్పుకున్నాం? అసలు వోల్టేజ్ ఏమీ అప్లై చేయని కండిషన్ని ఓపెన్ సర్క్యూట్ పిఎన్ జంక్షన్ అని చెప్పుకున్నాం అనమాట. అప్పుడు ఏం జరిగింది? ఓపెన్ సర్క్యూట్ పిఎన్ జంక్షన్లో డిఫ్యూజన్ ఆఫ్ ఆల్ ది చార్జ్ క్యారియర్స్ ఫ్రమ్ హై కాన్సన్ట్రేషన్ ఏరియా టు ది లో కాన్సన్ట్రేషన్ ఏరియా అని చెప్పి చెప్పుకున్నాం అక్కడ ఓపెన్ సర్క్యూట్ పిఎన్ జంక్షన్ డయోడ్లో. by applying some voltage to the PN junction diode, then the diffusion of all the then the drift will takes place. Then the drifting of majority charge carriers towards one terminal to the another terminal will takes place, and the drastic flow of current will takes place due to the movement of the electrons అని చెప్పాం కదా, అదే కాన్సెప్ట్. దట్ ఈస్ డ్రిఫ్ట్ కాన్సెప్ట్ ఈస్ విత్ రెస్పెక్ట్ టు బై అప్లయింగ్ ద వోల్టేజ్, whereas diffusion concept is a natural process. The diffusion of diffusion of charge carriers will takes place from high concentration area to the low concentration area. Similarly here, the same whatever the concept is there, that is applied here. దాన్ని ఏమంటారో చెప్తున్నాడు అన్నమాట. When no battery is connected between different terminals, transistor is said to be unbiased or open circuit stage అంటాడు అనమాట. Unbiased condition, that position we may treat it as unbiased condition or open circuit stage position, like that. Next one, the width of the two depletion layers will be different because the regions are doped at different levels here. The width of the two depletion layers, that this is the width of two depletion layers. This is one depletion layer, this is another depletion layer. The width of the two depletion layers will be different because of the regions are operated at different levels. అంతే కదా. This region is operated in forward bias condition, this region is operated in reverse bias condition, like that. The width is mainly depends upon the whatever these layers, depletion layers are will be the different because of the regions are doped at different levels. ఈ regions డోపింగ్ డిఫరెంట్గా చేస్తున్నాము, అప్లైడ్ వోల్టేజ్ కూడా డిఫరెంట్గా చేయటం వల్ల దట్ విత్ ఈస్ గోయింగ్ టు బి becomes thin. It will become thin or shrinking position, or it will become an elongation or in the enhancement position, like that. It is going to be ఫార్వర్డ్ బయాస్ చేస్తే షరింకింగ్ పొజిషన్లో ఉంటుంది, థిన్ పొజిషన్గా అయిపోయింది అనమాట. అదే రివర్స్ బయాస్ అప్లై చేస్తే అదే డిప్లీషన్ లేయర్ ఎలాంగేట్ అవుతుంది, వైడర్ అవుతుంది అనమాట. widening of the depletion layer will takes place by applying that reverse bias. Okay. That is the meaning here. The width of the two depletion layers will be different because the regions are doped at different because the regions are doped at different levels here. Okay. Emitter depletion layer is small and collector depletion layer is large. We know this one. Emitter depletion layer is small. Why? Because it is forward bias condition, forward bias voltage. That means positive voltage is applied to that region. That is to these two terminals. These two terminals. This is connected to negative, and P terminal is connected to positive. And then this diode emitter base junction is in forward bias condition, and this P terminal is connected in negative, and the n terminal is connected to positive, then it is in reverse bias condition. Then I can treat this region, these two layers are in reverse bias condition. Then this depletion region is going to be large here. That is the meaning here. Emitter depletion layer is small, whereas collector depletion layer is large. In this way, we need to explain the three terminals as well as biasing conditions as well as, and how by applying the biasing condition, how the depletion layer is formed, as well as what is the position of depletion layer is also important here. ఫస్ట్ ఏం చెప్తున్నాము, దానికి ట్రాన్సిస్టర్ని తీసుకున్న తర్వాత ఇట్ ఈస్ ఏ త్రీ లేయర్డ్ డివైస్. ఇట్ కన్సిస్ట్ ఆఫ్ త్రీ లేయర్డ్ ఇట్ ఈస్ ఎ త్రీ లేయర్డ్ డివైస్ ఇన్బిల్ట్లీ కన్సిస్ట్ ఆఫ్ టూ డయోడ్స్ అని చెప్తున్నాం అనమాట. Those diodes, one diode I am going to treat one diode as emitter diode, which is between emitter and base, and another diode is the collector diode, which is between collector and base. Base terminal is the common terminal అనుకోండి. Base terminal is common terminal between emitter and collector. And this is regarding first diode and regarding second diode. This emitter based diode is going to be forward bias condition, and a collector based diode is going to be reverse bias condition. And if it is this diode is forward bias condition, means the flow of current is high, therefore resistance is small. Whereas here this is reverse bias condition, the flow of current is low and that resistance is very high. If I am not going to apply, I'm not applying any sort of voltage to this circuit, I can treat that circuit as open circuit condition or unbiased condition అని చెప్పి చెప్పుకోవచ్చు అనమాట. Unbiased condition or open circuit condition. The width of the depletion region will be different because the regions are doped at different levels అని చెప్తున్నారు అనమాట. Width of these regions are going to be different. Why? Because the doping levels as well as applied biasing condition state, that region is going to be varied. Okay, just a minute. Next one, this is the depletion region at JE is thin. Why? Because it is forward bias condition. Let me write that one. This is JE is in forward bias condition, that is at forward bias condition. Therefore JE is going to be depletion region at emitter junction is thin. Why? Because the flow of current is high. Therefore automatically this resistance is going to be low or small value. Here the collector junction, this collector and the base terminals are in reverse bias condition. Therefore that collector diode is in reverse bias condition. Depletion region for this collector diode is large here. Why? Because it is reverse bias. Depletion region automatically elongates. Therefore the flow of current is very small. Therefore flow of current is small. Therefore this resistance is large here. This resistance get increases or large value. Depletion layer formed at collector junction is larger than the depletion layer formed at emitter junction. The same point is repeated twice here. Only this point, the meaning of this point is this one. Depletion layer of collector junction is larger than that of the depletion layer at emitter junction. Okay. This is regarding layered diagram. This is regarding the layered diagram representation as well as how many diodes are present in the how many diodes are present in the transistor. Each and every layer you are supposed to explain each and every layer, as well as what is the biasing condition of three terminals biasing condition. By applying that biasing condition, how the resistance part as well as current part we need to explain here, as well as the width of the depletion region, variation, how the depletion region variation is going to be takes place, you are supposed to tell. Okay, this is regarding the laid diagram of NPN type of transistor. Next one, biasing of transistor. That means applying some voltage to the transistor. I can call this as biasing of transistor. Biasing of transistor. This biasing of transistor, before going to the biasing state, we need to, we have two type of transistors, though that is two type of transistor, that is PNP type and NPN type of transistor. PNP type and NPN type of transistor. This PNP and NPN type of transistor, I am supposed to give some voltage supply to the త్రీ టెర్మినల్స్. అక్కడ ఉన్న త్రీ టెర్మినల్స్కి మనం సమ్ వోల్టేజ్ సప్లై ఇవ్వాలన్నమాట. దాన్ని బయాసింగ్ కండిషన్ అంటాం అనమాట. పిఎన్పి టైప్ ఆఫ్ ట్రాన్సిస్టర్ని ఎన్పిఎన్ టైప్ ఆఫ్ ట్రాన్సిస్టర్కి రెండిట్లకి కూడా some voltage we are supposed to provide or apply some voltage to the PNP type and NPN type of transistor. Okay, that is we are going to give here biasing of transistor. We will see emitter base junction is always, we have seen this one already, we have seen this one. This is emitter base junction is always forward biased and collector base junction is always reverse biased. Emitter base junction is always forward biased and collector base junction is always reverse biased. This is the point you need to memorize all the time, all the time. Why it is going to be forward biased and reverse biased, we will see. Okay. Hmm. This is the P type material, N type, P type, that is a whole. As a whole, we can treat this as PNP type of transistor. From this P type, this is emitter terminal, N type base terminal, and P type, that is collector terminal. I am just for easy sake, for easy representation sake, I am giving the emitter base collector terminals also. Okay. This is the laid type of diagram. Emitter base junction is emitter and base junction. These two, emitter and the base junction, should be forward biased. Okay, and this collector and base junction should be reverse biased. This is the phenomena we need to follow. Depending upon that, I am going to apply some voltage here. That condition is known as biasing condition here. That condition is biasing condition. Here, emitter terminal, this emitter terminal is P type of semiconductor material. ఇక్కడ వినాలమ్మా, ఇక్కడ ఇది చాలా ఇంపార్టెంట్. ఒకసారి కాన్సన్ట్రేట్. This emitter terminal is the P-type semiconductor material. P-type semiconductor material is connected to positive and N-type semiconductor material is connected to negative. Then it is in, then it is in, I can represent this as the biasing condition is forward bias condition. I'm going to give the name as forward biasing condition of this input side anukunda. For let it be, this is the input side and this is the output side. Let it be, this is the next one. It should be reverse biased kada. Collector and base terminals should be, always should be, these two terminals should be reverse biased. Therefore, this N-type semiconductor material is connected to positive and P-type semiconductor material is connected to negative. From the emitter, from this emitter, this is the position, this emitter, the flow of current is taking place in this direction. In this direction, some flow of current is flow to this base. Some small amount of current is going to be flow to this base terminal, and majority of the current is flowing towards the collector. That means from, this is the normal conventional current flow, that is from emitter to via base. This is the majority current అనుకోండి సింపుల్గా. emitter current that is going to be flow, that is majority charge carrier current, that is going to be flow along the direction of base towards collector. That means emitter to base, base a small amount of current. This medium, this is the base terminal, acts as a medium between acts as a medium here, that is towards that flow of current is actually going to the collector only. Okay. In the similar fashion, this is the layered type of diagram. Layered type of diagram లో మనకి ఈజీగా ఎట్లా ఫార్వర్డ్ బయాసింగ్ రివర్స్ బయాసింగ్ ఈజీగా ఉంటుందన్నమాట. కానీ మీరు వన్స్ సింబాలిక్ రిప్రజెంటేషన్ చేసేటప్పుడు కొంచెం కన్ఫ్యూజన్ వస్తుంది అనమాట. అందుకు ఆ కన్ఫ్యూజన్ రాకుండా ఏం చేయాలంటే యు ఆర్ సపోజ్ టు రైట్ దిస్ వన్. ఇప్పుడు పిఎన్పి టైపు ఎన్పిఎన్ టైపు వేసుకున్న తర్వాత, ఆ సింబల్ వేసుకున్న తర్వాత ఇది పైన రాశారనుకోండి, అది దట్ ట్రాన్సిస్టర్ ఇస్ ఏ పిఎన్పి ఆర్ ఎన్పిఎన్ అని పైన రాసుకుంటే యారో మార్క్ ఈస్ టువర్డ్స్, యారో మార్క్ ఈస్ ఇన్వర్డ్స్ ఉందనుకోండి, దట్ ఈస్ పిఎన్పి. పిఎన్పి అనే రిప్రజెంటేషన్ రాసుకుంటే యూ కెన్ ఈజీలీ apply some each and every terminal to the required terminals of the battery. We can easily apply, that is, this is the middle terminal is the n type, and these two extreme terminals are p type. That means this p type is connected to positive and n type is connected to negative. Similarly here this condition is known as forward bias condition. This n type is connected to positive and p type is connected to negative, then it is in reverse bias condition. This is forward bias condition, and this is reverse bias condition. Okay. In this way I am going to represent here. This is the emitter current, this is the emitter current, this is the base current, and this is the collector current. The flow of current is taking place from left to right. The flow of current is taking place from left to right. This current is mainly because of holes. This current is mainly because of holes. This current is flowing. Okay. This is about PNP type of transistor, NPN type of transistor. In this NPN type of transistor, similarly this N type, P type, and N type. Top of this N type, P type, and N type emitter, base, and collector terminals are represented. This N type is connected to negative, and P type base is connected to positive. Positive. Then I can represent this as forward bias condition. This region is forward biased. This region is forward biased. Here P type is connected to negative and N type is connected to positive. Then it is in reverse bias. That means whether we are using PNP type of transistor or NPN type of transistor, we are supposed to give the biasing condition as for input circuit, that is emitter base junction should be forward biased and collector base junction should be reverse biased. That is the representation is given here. That is same. This is the layered diagram. Symbolic representation. Symbol వేసాను. Arrow mark is upon this emitter. The arrow mark is outwards. Upon the emitter, the arrow mark is outwards. That is given here. This I am after drawing this symbol, I am writing this NPN. NPN. This what type of transistor it is. I am going to write here. That is NPN. After writing this NPN only, I can easily connect this each and every terminal to the voltage supply. That is n type terminal, n type n, this terminal is n type, is connected to negative, and p type is connected to positive. Here again p type is connected to negative, and n type is connected to positive. This is going to be reverse biased, and it is going to be forward biased. Like that I am going to given here. The flow of current is taking place from this emitter, and some small amount of current is flowing into the base, as well as flow of current is taking in this direction. In this direction the flow of current is going to be takes place. This is opposite of the కన్వెన్షనల్ ఫ్లో. ఇప్పుడు హోల్ ఫ్లో ఎట్లా ఉంది, మనకి లెఫ్ట్ టు రైట్ ఉందమ్మా. అదే ఇది ఇది ఎట్లా ఉంది, మనకి ఫ్లో కరెంట్ ఫ్లో ఎట్లా ఉంది, ఫ్రమ్ రైట్ టు లెఫ్ట్. ఫ్రమ్ రైట్ టు లెఫ్ట్ the flow of current is taking place in the NPN type of transistor. This is the electron flow. I can give the flow of current is electron flow here. Okay. This is the layered type of diagram and symbolic type of diagram. biasing of transistor can be given like this. Biasing of transistor given like this. And the same basic thing we are discussed here, we have discussed here means, that is how the forward biasing condition is applied to the emitter base junction, and how the reverse biasing condition is applied to the collector base junction. Okay, that is the main motto we have implemented here. And next one, that is the same whatever we have discussed with respect to this diagrams, that is theoretical part is given here. That is, emitter base junction of PNP transistor is forward biased by connecting the terminals of VEE to emitter, and the negative terminal of base and the collector base junction of PNP transistor is reverse biased by connecting negative terminal of VCC to collector and the positive terminal to base here. జస్ట్ మనం అక్కడ ఎట్లా అయితే కనెక్ట్ చేసామో దాన్ని ఇక్కడ థియరిటికల్గా ఇచ్చాడమ్మా. Emitter base junction of NPN transistor is forward biased by connecting negative terminal of VEE to emitter and the positive terminal to base. Collector base junction of NPN transistor is reverse biased by connecting positive terminal of VCC to collector, while the negative terminal is connected to base here. Forward biased emitter base junction forward biased emitter base junction has a low resistance path here. Low resistance forward bias condition లో ఉన్నప్పుడు automatically that flow of current is high and resistance is very low resistance path, whereas reverse biased collector base junction has a high resistance path. Reverse bias condition, the flow of current is very small, therefore reverse that resistance value is very high. A weak signal is introduced in low resistance circuit and the output is taken from the high resistance circuit. Normally weak signal is going to be introduced in the low resistance path లో ఒక వీక్ సిగ్నల్ ఇంట్రడ్యూస్ చేస్తాం. అదే హై రెసిస్టెన్స్ సర్క్యూట్లో అవుట్పుట్ ఈజ్ గోయింగ్ టు బి టేకెన్ ఫ్రమ్ ది హై రెసిస్టెన్స్ సర్క్యూట్ నార్మల్లీ అని చెప్పి ఇచ్చారు అన్నమాట పాయింట్. అది దట్ ఈస్ ద పాయింట్ గివెన్ హియర్. దిస్ ఈస్ ద రిప్రజెంటేషన్. One point, this voltage I am going to apply it across the emitter side, so I am going to represent that voltage as VEE. Okay, this voltage is going to be given across the collector side. I am going to represent that voltage as VCC. That means here emitter is connected to positive terminal of VEE. Collector base terminal is connected to negative terminal of VEE అని చెప్పి చెప్తున్నాడు అనమాట అక్కడ థియరిటికల్ పార్ట్లో. అది మీరేం కన్ఫ్యూజ్ అవ్వక్కర్లేదు. మనం వోల్టేజ్ మనం ఇక్కడ ఏమనుకున్నాం, బ్యాటరీ అనుకున్నాం. ఆ బ్యాటరీని రిప్రజెంట్ చేస్తుంది ఏంటంటే ఎమిటర్ సైడ్ కనెక్ట్ చేసాం కాబట్టి ఆ వోల్టేజ్ని విఈ అంటున్నాడు. కలెక్టర్ సైడ్ కనెక్ట్ చేస్తున్నాం కాబట్టి ఆ వోల్టేజ్ని విసిసి అని చెప్తున్నాడు అనమాట. దిస్ బేస్ టెర్మినల్ ఈస్ కనెక్టెడ్ టు పాజిటివ్ టెర్మినల్ ఆఫ్ విసిసి అండ్ కలెక్టర్ టెర్మినల్ ఈస్ కనెక్టెడ్ టు నెగిటివ్ టెర్మినల్ ఆఫ్ విసిసి. Similarly here n type, that is emitter terminal is connected to negative terminal of VEE and base terminal is connected to positive terminal of VEE, and P type semiconductor material, that is base terminal is connected to negative terminal of VCC and the collector terminal is connected to positive terminal of VCC. Like that we are going to write in the theoretical part. Representation, just representation. This is the input side, this is the input side, and this is the output side. Simply further what is input side and output side, in further subsequent classes we are going to see what is input circuit side and output circuit side, and we can call this as emitter side also. Emitter base junction and collector base junction. This is emitter side and this is collector side. This is going to be forward bias condition. Emitter base junctions are going to be forward bias condition and this is going to be reverse bias condition. Okay, forward bias condition as well as reverse bias condition. This representation of voltage is VEE and VCC. Okay, that is the same, that notation is given in the theoretical part. Here next, different operating modes of transistor. There are different operating modes of transistor are present here. There are four possible ways of biasing ఏ ట్రాన్సిస్టర్. ఇప్పుడు బేసిక్ బయాసింగ్ మనం చూసాము. ఇప్పుడు ఇది బేసిక్ బయాసింగ్ అనమాట. మనకేం తెలియదు. ఇన్పుట్ ఏమో ఫార్వర్డ్ బయాస్కి అప్లై చేసాం. అవుట్పుట్ సర్క్యూట్ సైడ్ ఏమో రివర్స్ బయాస్ అప్లై చేసాం. అంటే ఎమిటర్ జంక్షన్ ఏమో ఫార్వర్డ్ బయాస్ కండిషన్, కలెక్టర్ జంక్షన్ ఏమో రివర్స్ బయాస్ కండిషన్ అప్లై చేసాం అనమాట. అది మాత్రమే తెలుసు. అసలు ఆ రీజన్స్ని, ఆ బయాసింగ్ కండిషన్ రీజన్స్ని ఏమేమి రీజన్స్ అంటారో చెప్తున్నాడు అనమాట. ఇప్పుడు ఆ బయాసింగ్, ఇప్పుడు దిస్ ఈస్ ది నార్మల్ బయాసింగ్ కండిషన్ ఆఫ్ ట్రాన్సిస్టర్. ఆఫ్టర్ దట్ I am going to give some names here. This transistor is operated in this region. This transistor is operated in this region. ఆ ఫార్వర్డ్ బయాస్, రివర్స్ బయాసింగ్ని డిఫరెంట్ లెవెల్స్లో అప్లై చేస్తే అది ఆ రీజన్స్ని ఒక డిఫరెంట్ పెక్యులర్ నేమ్స్తో రిప్రజెంట్ చేస్తున్నాం అనమాట. ఆ పెక్యులర్ నేమ్స్నే ఇప్పుడు మనం వీఆర్ గోయింగ్ టు డిస్కస్ హియర్. ఓకే, this is there are four possible ways of biasing a transistor, and these are called as modes of operation of a transistor. Biasing states ni different operating state of the transistor is done by biasing of the transistor, that is emitter base junction, collector base junction, and the region of operation. Emitter base junction ni, collector base junction ni, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఫార్వర్డ్ బయాస్ మనం ఇప్పుడు చూసిన కండిషన్ ఏంటి? ఇప్పుడు దా చూసింది మనం ఫస్ట్ వన్ కండిషన్ వీ హ్యావ్ సీన్ దేర్. దట్ కండిషన్ ఈస్ దిస్ వన్. ఎమిటర్ బేస్ జంక్షన్ ఏమో ఫార్వర్డ్ బయాస్ కండిషన్లో చూసాం. కలెక్టర్ బేస్ జంక్షన్ ఏమో రివర్స్ బయాస్ కండిషన్లో చూసాం. దట్ రీజన్ ఐఎమ్ గోయింగ్ టు రిప్రజెంట్ దట్ రీజన్ యాజ్ యాక్టివ్ రీజన్. This active region is very important for our transistor to be operated in active region. Then only this transistor can be called, this transistor can be by proper operation of this transistor, that is active region. Then this transistor can be, the basic application of this transistor is the amplifier. ఈ యాక్టివ్ రీజన్లో ఆపరేట్ అయితేనే మనం దాన్ని ట్రాన్సిస్టర్ కెన్ బి ఆపరేటెడ్ యాజ్ యాంప్లిఫైయర్ అనమాట. యాక్టివ్ రీజన్ ట్రాన్సిస్టర్ కెన్ బి ఆపరేటెడ్ యాజ్ ఏ యాంప్లిఫైయర్ హియర్. That's why this transistor always should be operated in emitter base junction should be forward biased and collector base junction should be reverse biased. The active region example for this active region application is amplifier. How it is going to be done we will see in the later on classes. Okay, for time being, active region basic application, that is amplifier here. Next one, forward bias. This emitter base junction is forward biased and as well as collector base junction is also forward biased. Then that region I am going to represent that region as saturation region here. I am going to represent that region as the saturation region. Okay, next this emitter base junction is reverse biased. This emitter base junction is reverse biased and the collector base junction is also reverse biased. I am going to represent that operating region, that operating region of operation or operating region as cutoff region here. Cutoff region. Next one, emitter base junction is reverse biased as well as collector base junction is forward biased. Then region of operation is inverted here. Then this region of operation is inverted, and I can also represent this inverted active region also. I am going to give the name as inverted active region. Active region ఏం చేసాం చూడండి ఒక్కసారి. యాక్టివ్ రీజన్లో ఏం చేసామమ్మా? emitter base junction is forward biased and collector base junction is reverse biased, whereas the two terminals, that means biasing condition of these two terminals are reversed here. That means emitter base junction is reverse biased and collector base junction is forward biased. That region of operation, I can call that region of operation is inverted active region here. Active region, forward bias, reverse bias means first region of operation is active region. Both the terminals are in forward bias condition means I am going to represent that region as, I am going to represent that region as saturation region. If both the terminals are applied for reverse bias condition, that region of operation is cutoff region. This saturation region, this transistor acts as a on switch. In the cutoff region, this transistor acts as a off switch. సాచురేషన్ రీజన్లో యాక్ట్ చేస్తే ట్రాన్సిస్టర్ని ఆన్ స్విచ్గా యాక్ట్ చేస్తాం. అదే కట్ ఆఫ్ రీజన్ అయితే ట్రాన్సిస్టర్ ఈజ్ గోయింగ్ టు బి ఆపరేటెడ్ ఇన్ కట్ ఆఫ్ రీజన్. దిస్ ఈస్ ది బేసిక్ ఆపరేషన్. This inverted active region, we can call this as inverter. Simply we can call this is the inverter type of applications, we can use this type of biasing condition of the transistor. First two, emitter base junction is forward biased and collector base junction is reverse biased, means that is active region. Next one, both the regions, emitter base junction and collector base junction, both are forward biased, means saturation region. Next, both the regions are reverse biased, means that is cutoff region. And emitter base junction and collector emitter base junction is reverse biased and collector base junction is forward biased, then that region is known as inverted active region. Okay, are you is it clear? Is it clear? These four regions are very important. ఈ ఎంటైర్ యూనిట్ కూడా, ఈ ట్రాన్సిస్టర్ ఎంటైర్ యూనిట్ కూడా ఈ రీజన్స్ కిందే చూస్తుంటాం అమ్మా. మెయిన్ ఈ రీజన్స్ని బేస్ చేసుకొని చెప్తుంటాం. ఫర్దర్ డిస్కషన్ అంతా కూడా ఈ ఫోర్ రీజన్స్ మీద డిపెండ్ అయి ఉంటుంది అనమాట. ట్రాన్సిస్టర్ ఎట్లా ఆపరేట్ అవుతుంది ఏంటి అనేది ఎక్స్ప్లెయిన్ చేసుకోవటం మొత్తం కూడా దీస్ ఫోర్ రీజన్స్ ఆర్ వెరీ ఇంపార్టెంట్ అండ్ క్రూషియల్ ఫర్ ఎంటైర్ ట్రాన్సిస్టర్ రిలేటెడ్ యూనిట్స్ అనమాట. ట్రాన్సిస్టర్ బయాసింగ్ కానీ ట్రాన్సిస్టర్ నెక్స్ట్ ట్రాన్సిస్టర్ బయాసింగ్ యూనిట్ వస్తుంది అనమాట. ఆ బయాసింగ్ యూనిట్లో కూడా వీఆర్ గోయింగ్ టు టెల్ దిస్ యాక్టివ్ రీజన్, సాచురేషన్ రీజన్, కట్ ఆఫ్ రీజన్ అండ్ ఇన్వర్టెడ్ రీజన్స్ ఆల్సో. ఓకే, this is about region of operation. Next one, this is the first region of operation, active region. In this mode or region, emitter base junction is this junction. Emitter base junction is forward biased and the collector base junction is reverse biased. Emitter base junction, this is the emitter base junction is forward biased. This is forward biased and the collector base junction is reverse biased. This is the n-type semiconductor material is connected to negative and p-type is connected to positive. Then it is in forward bias condition. Forward bias condition. Okay, this p-type is connected to negative and n-type is connected to positive. Then it is in reverse bias condition. Then this transistor is operated in active region. This is the, in this way we are just explaining. This is simply we are just connecting emitter terminal to negative and base terminal to positive. That is with respect to this one. This layered type of NPN or PNP type of transistor depends upon this one. I am going to connect to the negative terminals as well as positive terminals here. In this emitter base circuit, a battery VEE is connected such that negative terminal of battery is connected to emitter while positive terminal is connected to the base. Positive terminal is connected to the base. Similarly, a battery VCC is connected to collector base circuit. Positive terminal of battery is connected to collector while negative terminal is connected to the base. In this region, transistor is used for, in this region, transistor basic application of this region is amplification. We can do some amplification process in this region only. Active region లో ఆపరేట్ అయితేనే మన ట్రాన్సిస్టర్ ఈజ్ యూస్ఫుల్ ఫర్ amplification purpose. Amplification purpose కి యూజ్ అవ్వాలి అంటే our transistor should be operated in active region. This is the point you should memorize here. Okay, and next one is, this is the active region. Next one is saturation region. In this saturation region, in this mode or in this mode of operation, emitter base junction and collector base junctions both are in forward bias condition. And this is forward bias. This is n-type semiconductor material is connected to negative and the p-type is connected to positive. Here this is n-type semiconductor material is connected to negative and p-type is connected to positive. That means this region as well as this region both are in forward bias. This is in forward bias condition. Both are in forward bias condition. Both the regions are forward bias condition. Then this region, this is the operation. This transistor is going to be operated in saturation region. Just this is the theoretical part. Negative of battery VEE is connected to emitter and positive of battery is connected to base. And similarly, negative of battery is connected to collector negative of a battery VCC is connected to collector and positive is connected to base. base. In this case, collector current becomes independent of base current. In this case, how it is going to be trends, we will see later on. Just uh, just in this case, collector current becomes independent of base current. So the transistor is just like acts as a closed switch. Then transistor is going to be in the on state అని చెప్పి చెప్పుకోవచ్చు అనమాట. Saturation region, in the saturation region, our transistor is going to be in the on state, or it is in the, it acts as, this transistor is acts as a closed switch here. Okay, this is about saturation region position. Next one, cutoff region. Cutoff region, in this region both the junctions are reverse biased. In this region transistors has practically zero current. This region is reverse biased, as well as this region is also reverse biased. This emitter junction as well as collector junctions both are operated in reverse bias condition. Therefore it will produce no current anamata, zero current. It is going to produce zero current, and it is not going to emit any sort of electrons in this entire circuit. Therefore the flow of current is almost zero. Of course there is a negligible small amount of current is going to be flow due to the minority charge carriers. ఇది reverse bias లో ఉన్నప్పటికి కూడా from the depletion regions some small amount of minority carrier current flow will take place from the p-type semiconductor material as well as n-type semiconductor material. Due to that flow of minority charge carriers, small amount of current will flow. In this situation both the regions, emitter region and collector region, both the regions are operated in reverse bias condition. Therefore this transistor acts as a open switch here. This transistor acts as a open switch, or we can represent this as this position of transistor as off position. ఆఫ్ పొజిషన్ అని చెప్పి అంటాం అనమాట. ఓపెన్ స్విచ్ అన్న అంటాము, ఆఫ్ పొజిషన్ ఆఫ్ ది ట్రాన్సిస్టర్ అని చెప్పి చెప్తాం అనమాట. దట్ మీన్స్ దిస్ ఈస్ ఎన్ టైప్ ఈస్ కనెక్టెడ్ టు పాజిటివ్, పి ఈస్ కనెక్టెడ్ టు నెగిటివ్ ఆఫ్ విఈ, and this is n type, that is collector terminal is connected to positive, and base terminal, that is p type semiconductor material, is connected to negative. Then this is in reverse bias. This is in reverse bias condition, and this is also in reverse bias condition. Both are in reverse bias condition. That region of operation is cutoff region. Cutoff region, it's in this region transistor acts as a off switch here, off switch or open switch. Okay, and next one is inverted active region. In this inverted active region, in this region emitter base junction is reverse biased. This region is going to be reverse biased, and the collector base junction is going to be forward biased here. That means this is the n type semiconductor material is connected to positive, and the p type is connected to negative. That means it is in reverse bias position. This is this is in reverse bias position, whereas collector side this is in forward bias position. This n type is connected to negative, and p type is connected to positive. That means input circuit side it is forward biased, while output circuit side it is input circuit side it is reverse biased, while output circuit side it is forward biased. This position, this region of operation, or this position, this mode of operation, I can treat this mode of operation as inverted active region. I can represent this region as నార్మల్ కండిషన్ అయితే యాక్టివ్ రీజన్ అంటాం. ఇది రివర్స్లో ఉంది కాబట్టి ఇన్వర్టెడ్ యాక్టివ్ రీజన్ అంటాం అమ్మా. ఇన్వర్టెడ్ యాక్టివ్ రీజన్. ఓకే, this here this is in this region emitter base junction is reverse biased, and the collector base junction is forward biased. Collector current cannot inject into the majority carriers in the base, because the doping levels of the emitter and the collector is not the same. Therefore the action of transistor, the action in this operating region, the action of the transistor is very poor. It is not at all considerable anamata. Normally transistor should be operated in active region only. This inverted active region will give the performance of the transistor in the degrading state. It is going to be happen if our transistor is operated in this inverted active region. Okay, it is most of the applications we are not going to see in this active regions. Okay, inverted active region. Next one, further Further, the operation of PNP and NPN transistor we are going to discuss in the next class. Okay. Till now, please read once again. Once again, I will put this material PDF material in our Edmodo only. ప్లీజ్ లుక్ ఇన్ టు దట్ అండ్ రీడ్ వన్స్. ఇప్పుడు క్లాస్కి వచ్చే ముందు ఒక్కసారి చదువుకొని రండమ్మా మీరు. నేను చెప్పిన ఇప్పుడు ట్రాన్సిస్టర్స్ నుంచి ఆ పని చేయాలి. ఎందుకంటే ఇది ఒక్కసారి చూస్తే రాదనమాట. మనం ప్రాక్టీస్ చేసుకోవాలి. రెగ్యులర్గా ప్రాక్టీస్ చేస్తేనే యూ కెన్ కమ్ అక్రాస్ వాట్ ఈస్ ద సింబల్, వాట్ ఈస్ ద లేడ్ డయాగ్రామ్ ఆఫ్ ట్రాన్సిస్టర్, వాట్ ఈస్ ద సింబల్ డయాగ్రామ్ ఆఫ్ ట్రాన్సిస్టర్, వాట్ ఈస్ how the current is going to be flow from one terminal to the another terminal. అవన్నీ కరెంట్ ఫ్లో డైరెక్షన్ కరెక్ట్గా లేకపోతే మీరు ఎన్ని సర్క్యూట్లు వేసినా సరే వేస్ట్. ఆ సర్క్యూట్ డయాగ్రామ్ మీరు ప్రాక్టీస్ చేస్తేనే, మీరు ప్రాపర్గా ప్రాక్టీస్ చేసుకుంటేనే మీరు ఇంటర్నల్ ఎగ్జామ్స్లో కానీ ఎక్స్టర్నల్ ఎగ్జామ్స్లో కానీ మీరు నీట్గా రాయొచ్చు అనమాట ఎగ్జామ్. ఓకేనా? అందుకని ఒకసారి ఇప్పుడు చెప్పిన క్లాసెస్ మొత్తం ఒక్కసారి రిపీట్ చేసుకోండి. నేను ఆ మెటీరియల్ మీకు ఎడ్మోడోలో పెడతాను. ఓకేనా? Okay, please go through once again for the last 2 sessions. Okay.